Hi everyone, my name is Louisa and today I'm going to be teaching you about how we can find resistance in a complicated circuit. This is the third example video I'm doing on this topic, and today I'm going to try and show you some of the tricks that you might come across and how those tricks can actually be solved pretty simply. Alright, so I've drawn again a fairly complicated looking circuit, and I want to draw your attention to mainly one thing. This used to trip me up when I was first learning circuits myself. You can see here that I've got a path, a part of the circuit that's at a diagonal. And that looks like it's going to be really tricky because you're like, I don't know if it's in series or in parallel. So the very first step when you see a circuit like this is you're going to want to redraw it in a way that's much clearer. So what I'm going to want to do is I'm going to want to move this resistor. I'm just going to draw it up here when I redraw it because it's easier to tell that they're in series and they're next to each other. That's just my preference. You don't have to do that. And I'm going to redraw this angled part so that it's clear the way it works. And when I draw it, you're going to understand how it will work in this circuit. So let me redraw this circuit for you, and hopefully you'll see what I mean. Alright, so this is the exact same circuit. I haven't even simplified it. The only thing I changed was I moved this loop up to this side, the exact same thing. I moved this diagonal, and I made it simply a very easy to understand parallel. I also moved this just down so it was on the same side as this one, so you can just see more easily that we've got two resistors in series here. So now we have the exact same circuit, nothing has been simplified, and we're just going to go ahead and solve it the way we learned how to. Alright, I'm going to erase this top circuit so I have more space. Let's start with the smallest units. I'm going to circle them in red. These two are just in parallel with each other, and there's nothing else interacting with them at that small level. These two are in series, and again, there's nothing else. Neither of them is in parallel with anything else. That's easy to simplify, and then these two are in series. So I'm going to redraw the circuit on top of this and make it a little bit bigger and make those replacements. Before I do that, let me just assign the value R to every resistor. So as I've done in the past, I'm going to go ahead and assume that these resistors are all identical. They all have the same resistance. And so the answer we're going to find is going to be in terms of R. Alright, so now when I draw these values in, I'm going to make some replacements. Since this was two resistors in series, both with value R, the new resistance is going to be 2R. Because when they're in series, you just do R plus R equals R equivalent, and we get R equivalent equals 2R. We're going to do the same thing for this series on the end here. We have two in series, both of resistance R, and we're going to say R plus R equals R equivalent, which is 2R. We're going to replace this with 2R. And now we're going to do this one in parallel. And we know the formula for finding in parallel is just 1 over R plus 1 over R equals 1 over R equivalent. Normally this would be R1 and R2, but since we're only looking at R, the variable R, we can just say R. And so we're going to end up with 2 over R, and R equivalent is going to be R over 2. I'm going to erase this now so I have a little bit more space. And now I'm going to erase the entire bottom circuit since I've redrawn it above. Oh, the only thing I forgot to do is write in the value R for this